What's up, everybody? Welcome back. Today we are kind of working on my map, and today's project is trying to write a protobuf parser. So for context, we are writing this map because we want to be able to generate our own tunable bus route path planning algorithm, right? So we have this concept right now where blue lines on here are bus routes. If I try to plan a path, he's walking along, he's taking the bus. Wow, pretty good. Where there are like some tweaks that we have to do to this path planner to try to make it work a little better. But like here you can see he's doing stuff like he's deciding that to go right here because that will hit this transfer timing a little better and then come back. That's faster than going here and then going this way. Stuff like that. We have like the most basic algorithm here right now where he just kind of looks at like time effectively and tries to like minimize time. We want to do better than that. And one of the things that we want to do in order to do better than that is we want to look at consistency of bus schedules, because something that really like irritates me is when I use Google Maps and I say, how do I get it from one place to the other? And he says, take these 3 buses and these, you're going to take this transfer. And if one of the buses is a little late or even worse, a little early, then I might miss the transfer and then I have to wait 30 minutes for the next bus, and that like kind of irritates me. And so something that I wanted to look at was trying to get this concept of like bus consistency, right? So I'm kind of imagining that if like for each stop, right, there's going to be some sort of like, if this is like time, right? Time. There's going to be like some scheduled time where the bus is supposed to get there. And what I imagine is that there might be some sort of distribution of like, sometimes the bus is early, sometimes the bus is late. Maybe it looks kind of more like this, right? Like something like this, because like probably the bus driver will like stop at the stop and wait if he's too early, but maybe like if he's a little early, he'll just keep going. Or if there's like another bus coming right there, like close by, like he'll leave early. I don't know. I don't really know what like the rules are for how this stuff works. And so what I want to do is I want to scrape data about like real-time bus info and try to get some sort of distribution of like for this stop at this time, right? So like during rush hour we are going to be late, at like midnight we're going to be early. Like I want to kind of like get those pieces of information and use that in the path planner in some way. And so I was looking at Vancouver's TransLink thing, and I was trying to be like, hey, how do we get real-time transit information? And they're like, hey, there's this, this is like the old way, using this REST API. The new way is to use this GTFS-V3 API. I'm like, okay, what the fuck is that? And I like go here, and I like, grab this file, and it downloads in my browser as like tripupdate.pb. And I'm like, what the fuck is .pb? And they say, hey, check this out for more information. And somewhere they talk about in here data format. So these things are using protocol buffers. I'm like, okay, I guess we need to parse protocol buffers. And, if we were reasonable humans who worked a job in the real world, we would maybe use protobuf. We would like use the compiler, Protoc, and use libprotobuf and generate some code. Now, there isn't like an official Zig protobuf generator. So the way these like protobufs usually work is they have this like message format. Here, we can actually look. I downloaded their like specification, and so they kind of have this thing where they say like, hey, we are going to give you like a message feed header, and it's going to have like a string, it's going to have an incrementality field, it's going to have a timestamp. And what usually happens is you run like protobuf's compiler on this, and it will generate like, if you're generating for C++, it will generate like class feed header, and inside it will have like I don't remember what C++ looks like, I apologize, but it'll have like some like public function, and it's going to be like get GTFS real-time version or something, right? And it's going to return like a std string. And this is going to like look at some backing buffer and like figure out where in that buffer this string is, and like extract it and turn it into like the C++ version, etc. And we're just gonna like, there's not one of those generators for Zig, at least officially. There are like people have implemented some. In fact, Travis, who's in who's in my chat a lot, I noticed that he has in his GitHub repo his own version of this. And I think I want to just build my own, because like fuck it, right? Like I don't really want to I've been looking to take a little bit of a break from the map stuff anyway, so this is kind of like a nice little side quest that will like refresh us and is also important. I think it's important to understand data you're working with, and what better way to understand the data than to just fucking rip it yourself, Something interesting about protobufs are that they are supposed to be like an efficient binary representation. Um, so the idea is that like they get like packed pretty aggressively into this like on wire format. If I remember correctly, they do these like variable integer width things. So if you're you're using a uint 16, but the value is less than some number, it will get like squished into less than the uint 16 bits, whatever. But yeah, we'll see. I just kind of want to see if we can like extract any useful information from this like position updates thing. So I've downloaded position.protobuf, and I don't really have much of a plan other than try to like extract data from this. I think I'm okay with dodging the concept of like doing like the compilation to Zig, right? So like usually you would take these messages and you would compile them into C++ classes or Zig structs or whatever. I think I'm okay with kind of like doing the conversion by hand as long as we get the right data. So what this might end up looking like is it might end up looking as us reading this file manually and then deciding what the rules are to parse the file on Zig side. I don't know. We'll see how it goes. I don't really have any plan other than just fucking start and seeing what happens, right? So, I don't really like what's like the first place to start is probably like use Protoc to inspect anything, right? Let's just like see, do we have valid protobuf files? That's something that we need to confirm. And I did cheat a little bit, and I did run Protoc before this, just to make sure that they were in fact protobuf files, because it would be a problem if they weren't. But if I run Protoc protobuf, let's get the official protobuf compiler, and see what it looks like. And if we like cat this thing and we say like, hey, Protoc, you don't necessarily know what this thing is, but you know it's a protobuf. What information can we get from that? And he does get like, okay, so there's some struct here, and he has 3 fields, and the first one's a string, and it has 2 numbers, and here's your second type, and he has a string and a number, and like inside him type 3, and so there's like stuff going on in here. I don't really know what it is, but we can kind of figure it out from here, right? So I think we probably want to like Protoc print message. I think there's a way to do this. Print human-friendly protobuf message. Can we do it with like Protoc directly? I'm pretty sure it's possible. Print Protoc print file or something. Decode. Here we go. Here. Protoc decode. So this is the type, and this is the definition. So it's like, oops, fuck. Protoc decode. Yeah. Okay. So if we think that we have position.pb, and he came from this position update, so I guess we need to figure out what type we think is stored in that thing. So we can look at GTFS real-time proto, and we can just kind of take a guess here. So there's trip update, vehicle position. This looks promising. Vehicle position looks like it's probably the one. Alert position could be position. My guess is still vehicle position. So like is vehicle descriptor used inside of vehicle position? Yeah, so vehicle position has a trip descriptor, vehicle descriptor, position. It's gotta be this, right? Like that looks promising. So we can do like Protoc decode equals vehicle position, cat position protobuf, and we use this from GTFS real-time proto. Type not defined. Let's just go and look at this again. They are using like a namespace qualifier here. So they have package response and then message response. They're just calling response.response. So let's see if that makes sense. Transit real time. So we just do the same thing, but with transit real time stuck in front. Okay. That did something. It doesn't really necessarily feel right. Where we have trip ID 2. Not then like these like nameless fields, right? This doesn't feel like we decoded the right thing. So maybe we read the spec. Maybe we read their thing and we can see which data structure is used. So we are using, this came from position update, so GTFS position. How do we know? Ignored, like GTFS position, no. How do I know like what type comes out of this thing? Is there an example of what the protobuf looks like? I mean, I think it's like one of these messages. I don't really know what you're asking actually, so I'm just gonna keep going. I'm just gonna keep looking at, where the fuck did it go? Google Transit. So GTFS real time. So table 1, these are ignored by transit in real time feeds. So, okay, learn more, go to gtfs.org. Okay, real time. Feed entities. Service alerts, vehicle position, trip model. So it does feel like this. Vehicle position updates. You can also provide a vehicle descriptor. Vehicle position is used to provide automatically generated information on the location of a vehicle. So that came from, is this the same as position update? Maybe. Maybe. Feed entries. Trip updates. Service alerts. Yeah, it has to be vehicle positions. Which really feels like it is this vehicle position thing. Oh, maybe it's a feed entity or a feed message. The content feed message sounds very promising, huh? Like really promising, actually. So can we look at maybe this thing as feed message? Ah, okay. Wait. This looks like English. Hell yeah. Okay, so when we asked for positions, it says, hey, this is like an array of stuff. We are using GTFS version 2.0. We have a full data set, and here's when we got it. And then we have a bunch of entities in this thing, and each entity is a vehicle entity, and here is your information about it. Hell yeah, hell yeah. Now, let's just fucking run it and see if we can like figure out how to read this thing ourselves. You know? So let's try parse anything ourselves. Like literally anything. And I guess I don't have to say I don't know what time it is. I do know what time it is. 13:10 right now. Dude, I was working with like debugging some like Wayland stuff in happy hour, and my alt tab is broken, and I'm gonna lose my fucking mind. I'm gonna lose my mind because it's the only way I navigate, and so I have to fucking pick up my mouse and click on these icons at the bottom. Blah, gross. Okay. This document describes the protocol buffer wire format, which uses defines details of how your message is sent on the wire, blah, blah, blah. If I already know the concepts we want to reference, skip here. I don't know the concepts, but I do just want to reference. Because reading is for nerds, and we always say that around here. Okay, so this looks like some sort of like grammar definition. So probably your top level thing is your message. Your message is a list of repeating tag value pairs. So that lines up with what we saw from the Protoc output. And the tag is a field shifted left by 3 bit or wire type encoded as a U32 var int. Okay. And then here they have this like var int. This doesn't really explain what a var int is. This seems like the building block that we're going to need. Probably. But maybe we can look at, so message first comes with tag. He's kind of claiming off rip, you're going to see tag value. Okay, sure. So tag, and the tag is this thing. So how do the tags get converted into like these proto protobuf messages. That's a piece of the the piece that we're missing, right? This thing just says message, but we could maybe assume that the messages are in order of the way that they're defined in the protobuf. In fact, we could test this by just swapping the order of some of these around, right? If we take this and we put this up here, and all of a sudden we can't parse the file anymore properly. Fuck. I was certain that that was going to be it. So it looks like order here doesn't fucking matter. Like, I put trip update up at the top. And I run this again. And it seems just kind of like fine. So how do these things get mapped? That's unclear to me. It could be like a dependency tree. So they might find out that like feed message depends on something here. What if we just make something else ourselves? Like message sup dog. And he takes in like like an int. Like required int 32. Oh, we actually specifically said that we were looking for a feed message. So these numbers here must be the tag types. So if we swap this 2 and 1, then we should see it get totally fucked up. Yes. Okay, and we can actually see that here where the first thing is identified as a feed entity and the second thing is identified as a header. So we did swap them. Okay. So that makes sense. So we kind of start here, and so we want to make sure that like when we open this file, the first thing that we see should be a var int of number 1. That's what we should see when we open the file. XED maybe, or hex dump. Position. So the question is what the fuck is this? The first byte we see is 0A. So I guess probably we want to see if we can understand varants. Where the fuck is that defined? An application, you create test one message and set A to 150. You then serialize the message to the output stream. You're able to examine the encoded message. You see these bytes. So far, small and numeric, but what does it mean? Okay, base 128 varants. Variable with integers or varants are at the core of the wire format. They allow encoding unsigned 60. Oops, sorry, I just slapped my fucking mic. You might use std leb to read those. Really? Like in Zig, they have that? That's fucking crazy. Let's see. LEB. What is this? What the fuck is an LEB? LEB 128. Is this the same as a varant? Little endian base is a variable length compression used to store arbitrary large integers. Okay, we will see. Okay. So varants. Each byte is has a continuation bit that indicates if the byte that follows it is part of the varant. This is the most significant bit of the byte. Sometimes called the sign bit. The lower 7 bits are payload. Got it. So if we have 1 0 0 0 0 0 0 0 0 0 0, we see like probably just 0. If we see 1 0 0 0 0 0, like if we see everything as zeros, then the next byte does not follow. So then the question is, did we see that in our hex dump here? Here we see the first byte is A0A, which means that we are not continuing. So this does not look to me like a tag value of 1, based off everything that I know so far, which is nothing, right? Let's just be clear. We don't know anything yet. Let's go back down here. So they said it should be tag value. That matches up with here, I think. This is what they said as well. So here, let's see what this says. Let's read. So they're saying that this is the 1 here. This is confusing to me. Oh, no, wait. You set this to 150. Okay, let's just continue reading here and see if we understand it. OAOD is ASCII new line. Sir, surely that's not it, though. Surely. Message structure is a sequence of key value pairs. The binary version of a message just uses the field's number as the key. Okay, the name and blah blah blah. There are 6 wire types. The tag of a record is this. Oh, okay. So field number, so shifted left by 3, or wire type, bitwise or. So here it depends on what wire type we have. So let's look at the first byte of this thing, 0xa. And we shift this left by 3. Okay. So this is value of 1. So this is a fixed int 64. Oh no, sorry. This is the field number. So this is field number 1. Okay, yeah, that matches up. And then the wire type is 0. So we have a var int. Our first thing is a var int for field number 1. And does that match up with the feed message? Feed header. Interesting. So I would think, I don't really know what to expect from here. I guess we'll just keep going. So how do like nested messages work? Value is any of these things. Oh, because the top level message doesn't matter? No, it should. We should somewhere map this like, hey, we are fucking looking at the header. This needs to come from somewhere. This needs to come from somewhere. And I assume that that's like fucking off rip. Because we have field number 1. Okay. So I guess none of these wire types are talking about messages. Oh, Prime. Hey, wow. Thanks for the raid. What's up, y'all? Okay. 3,000 new people, so we have to do a reset a little bit. We are working on writing a protobuf parser in Zig. And the context for that is we're working on this map. We're doing transit planning. This is like a little red line trying to get us from here to here at 3 p.m. It's saying, hey, take this bus, then take that bus, then take that bus. That's kind of like where we're at to some extent. We were like really rudimentary bus planning. It's like it works okay if you don't care about transfers and you think that every bus is going to be on time, etc., etc. So the thing that we are working on right now is we are trying to look at our from Vancouver's TransLink thing. We are trying to basically fetch data about real-time bus info, and we're going to try to correlate that in some way with the schedules. And so we're kind of hoping that if we collect data over enough time, that we'll be able to get some sort of like consistency measure, and using that consistency measure, we can adjust whether or not we want to take some buses, right? So this stuff that came in, I downloaded this thing, and it's like, it's a protobuf. And I'm like, I don't know, like, we have to fucking read a protobuf? Gross, okay. And instead of using a library, which is less work and less fun, we're like, what if we just fucking do it ourselves? Because it's fun. And we are in this fun little world where we don't actually have to do the most effective thing. We just get to do the most fun thing for stream. And so that's what we're doing right now. What is a protobuf? Yeah, so protobuf that's what we're trying to figure out right now. So far, we have understood, we have looked at this grammar a little bit. So there's kind of like a specification. So you have like a message, right? And the message says like, here are some fields that I'm going to serialize. And there are rules for each field about like how they're encoded. We don't know what that is yet. We're trying to figure it out. But if we take our thing that we have right now and we say, hey, take this like position update and protobuf compiler, here is the definition for this thing. What is it? And we see in here that there's like a header, and he says there's a bunch of entities. Each of these entities is a vehicle, and the vehicle has some position, and he's a toast associated with some like bus route. So the protobuf compiler has some way of like processing this file, and we are now trying to decode it without it because we are losers. So that's where we're at. We have been reading this thing. So it looks like we've just started looking at like the very tippy top of the file, where we've read literally the first byte of the file, and we saw that he has 0xOA shifted right by 3 is 1, which lines up with somewhere they say the wire type, the field number and the wire type is this. Is this like for work? New here? This is for our map, and the map is for fun. We don't really do any work around here or anything of real value. We just have fun. And so right now I'm kind of like, I'm working on this map because Google Maps pisses me off, and when I have to go outside, I want to get not pissed off. It's kind of like the extent of it. Okay, so let's jump back in. Apologies for those of you who were here earlier and just had to have that explained to you twice in a row, but in this case, it's worth it. Okay, so message structure, key value pairs, tag of a record, field number, lift shifted left by 3, wire type. So we see that this says it's a var int, because wire type, the bottom 4 bits of this, wait, is that true? Wire type is, how many bits is this? 1 to 5. So this is 1 bit, 2 bits, 3 bits. So the low 3 bits tells the wire type. It does say that. I could have read with my eyeballs instead of making it up. But we did guess the right number. So if we look at like 0x A and the lowest 3 bits. Oh, that's 2. 2. Oh, wait, okay, so this makes sense. This makes sense. So if we see a field of length, that means that we have another message inside, and we need to find out how long that message is. So what is the len field? We can go back to our little like cheat card here. And len value is len prefix if wire type is len. And len prefix is size followed by one of these things. And this is an int32 encoded variable integer. So we're back to var ints on the next thing. So we can go back. And so we see kind of like something, we can be pretty certain that this 2.0 is like string content for the like thing we saw before, right? When we look here, we see GTFS real-time version 2.0. So we're confident that we're like done the integer by then. And we have seen so far that the var int encoding uses the most significant bit to flag if we continue. So this has the most significant bit is not set. So we are just looking at size as var int directly. So size of this thing should be just what's D, like 14, I think. FED. Yeah, 15, 14, 13. So the length of this thing is 13 bytes. So if we look at the next 13 bytes of this, or we jump over the next 13 bytes, we should then see the next item in the buffer. Yes. So if we jump over the next 13 bytes, we should see another tag with the value of 2 that's claiming its length. It's a length field of 2 at byte position 14, if we're parsing this correctly. I think. I don't fucking know, man. So 14 is here. Wait, this is 16, 15, 14. Although if length is 14 here, we need to go 14 past this. So this is 0, 1 plus 14 is 15. So maybe this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Unless this is included. I can't tell. Fuck. My poor little stupid brain. He's struggling here. I wonder if it makes sense to start trying to do this programmatically. We could start and just kind of see what happens. So what? We want like main. And we want to just like open some file. We need some standard library. Use a protobuf parser. That's not the point, okay? That's not why we're here. We're not here to do something effective. We're here to do something fun, and the fun thing is to do it ourselves. And I think that partially, it's also kind of important. Like, I think that doing this one time will make us understand the data better, and I think understanding the data is very just generally very, very useful. Maybe not required, but helpful. Or do something effectively fun. Yeah. Well, this is effectively fun for me. What is this file called? Position PB? Yep, this probably needs to be tried. And then we, I guess, read this into a vector, I guess, because I don't really want to deal with anything. We set some max file size of like a fucking gig, because it doesn't fucking matter. We get some allocator that comes from our general purpose allocator, which means that we need the general purpose allocator. Heap general purpose allocator, and we initialize this thing with like a fucking I don't give a fuck config, and then on exit we do like GPA dinit, and then we have this thing. So we have our buff is this, and then we read our first buff 0, buff 0, and we're gonna say like read fuck, alt tab's broken. Read tag. We're gonna call this read tag, and we're gonna read the tag value, and it's a byte, I guess, and he's gonna return us a tag, I guess, which means we have a tag. And here the tag has a, what was it? It has a field and wire type. Wire type. I guess we'll just throw these as ints for now. And so this is like field is tag shifted right by 3, and the wire type is tag and 0b111. That's what we saw, I believe. So we should be able to do like read tag of buff 0 and std debug print any of the tag. Wow. Bump. All right. Zig run test.zig. Apologies, I'm kind of ignoring the editor talk because I want to continue to make progress, and I don't think it's that important. Unfortunately. Okay, field 1, wire type 2. So this is, in fact, what we saw when we tried to parse by hand. And we are leakies. Leakies and squeakies. Squeaky leakies get the grease. So we dinit this free buffer. That's fine, we know you don't give a fuck about it. I mean, I care a little bit, just not enough to talk about it. It's kind of like a dead horse to beat, which is a fucked up saying. I don't think we should talk about beating dead horses. Beating a horse till it died and then continuing to beat it would be really fucked, actually. That's crazy that that's a saying that we use. Why not use a packed struct? Because it's not... I guess in this case it is packed. But mostly because I don't care. Is the real answer is like it's my philosophy going into this is going to be I want to convert this like shit show format on the disk into something that's like easy to work with in code. Use feed a fed horse instead. Perfect. I like that better. Okay, so now we think that we know that we want to switch on the wire type, so we're probably gonna want like wire type as an enum, probably. And we're probably gonna want to like just copy these into here. So we'll do something like get the fuck out of here, and then can you do like macro jump to the end, delete, comma, go again. Okay, and then we probably want to like lowercase all these. Okay, and then I don't know if these like are reserved words. This like I32, I64. It seems like it would be a little bit of a problem. Seems like you could just bitcast the instruct. Yeah, I know. Yeah, it's fine. I don't want to do it that way, so I won't. It's about the extent of it. Can we, like, is there a way in this language to automatically, is this how you say I want this to be U8? I think it is. I can't fucking remember. And then I think we just want to say, like, uh, stood meta, like, enum, int to enum. That feels right, from, like, wire type and using tag and 111. I guess that's 7. Yeah, okay. Wire type is this, and then we get wire type like this, and then wire type is like this. Let's see if that still is reasonable. He's mad because this thing can fail, which is reasonable, I think. Let's complain about. Yeah. Try, this can fail, which means that this can fail, and we try here. Boom. Enum from int. I think that enum from int assumes that it's valid, where the int to enum in stood meta does checking to ensure that you're, like, within the valid range, I think. What's that cool thing over your head? That is the ball machine. So we'll take a quick little look. If you go to spherophoria.dev, the idea behind this thing is each of these chambers is a WebAssembly module. And so you, if you wanted to, could make a WebAssembly module and you could upload it here. And then I could go in here and I could say, like, is there a WebAssembly module for me to accept? And the WebAssembly modules are responsible for, like, drawing and applying physics to the balls. And so the idea is that, like, people can upload their own, and then we can do basically anything you want, and then they show up. Okay. So we have the wire type and the tag. Sick. And we wanted to double check that the wire type is, in fact, what we wanted. And it does say wire type len. So we are chilling. And so now we can move on. So we wanted to parse the length now. So this is tag value, right? So the next thing is our value, and our value should be len prefix. So we should be able to say, get the size as a U32 variant. So we want some sort of, like, parse variant. Two-step was claiming that the LEB128 in the standard library is the same thing as a variant. I don't really know if that's true or not. I don't know how to check. LEB128 variant. Is this, like, or can I look up, like, protobuf LEB128? What is that LEB128? I don't know. I want to, like, these don't say the word protobuf in them. Can you please fucking... I mean, I guess we understand the format of the variant. It explains it in here somewhere, and we can just check if that's the same definition, I guess. So the variant is just... the first bit tells us if it's more, if there's more, right? So you take the last 3 bits to get the wire type, and then blah, 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 blah. Okay, where did it explain variant? That's here. Base 128. They allow, blah, each byte in the variant is a continuation bit, which is the most significant, the lower 7 bits of the payload. The resulting integer is built by appending together 7-bit payloads as constituent bytes. I don't know if, is it little endian or big endian here? 9601. So here we have, here, I assume that this is tacked on at the front. So the final thing is this section here slapped with this on top. Okay, so we can check if that's the same as LEB128. To encode an unsigned number using LEB128, first represent the number in binary, then 0 extend the number up to multiple 7 bits. The most 7 bits are break up the number into groups of 7 bits, output 1 byte for each 7-bit group. From the least significant to the most significant, each byte will have 1 group in its 7 least significant bits, blah, blah, blah. The most significant, blah, blah, blah. Okay. I think it's the same. Oh, it has a comment on protobuf compatibility. But encodes sign integers by prepending the sign as the least significant bit of the first byte. Ah. Gotcha. So we parse these as unsigned LEB128s and then do the sign conversion ourselves, which I guess makes sense. So we'll just call this read. This does, like, a lot of the work for us, which is really nice. What's the difference between these 2 functions? These look the fucking same. They have the same name. read u lub 128. Oh, maybe they just had the same. Yeah, it's fine. Fine. We'll do it that way. Read varint is, and then I guess we take in a like buffer, and we return like a new buffer, indicating how much we consumed. Seems kind of reasonable to me, I guess. And so we're gonna use like std lab read. This requires a reader. I guess the question is that how I want to do it? So he calls read byte. It feels like maybe this is like stupid, but it feels like using a reader is like unnecessary abstraction that I don't really want. But we could just kind of yoinkies this shit. And why does it look so complicated? Shift left with overflow. I see. Because where is this guy going into in his version? He's returning, so this is also generic, where he's kind of saying, depending on what type, I like have to make sure that I fit in that type. Which I see. So he's going like, hey, I overflowed in that case. That makes sense. Do we have to think about that? I guess, do we know do we know like the size of the thing that's being given to us? Not really, huh? How is like what is like the definition of these things in protobuf language? Int 32. So I don't know if these int 32s, if you write those as like numbers here, if these are expected to be like how do I say this? Like there's the i32 fixed size type as well as variable integer, and I don't know if like the message type in your protobuf definition like defines if you're going to be variable int or not. You know what I mean? Or if it defines like the output size of the variable int or max value or something. So in here, like I guess we could look at the protobuf types. It does look like they're all typed. And it does look like there's like int32, int64, uint32, uint64, and I'm pretty sure that doesn't match like the possible types. There's just i32 and i64, although oh no, these are my guess is that it chooses. Oh yeah, here it goes. Varint could be any of these things and coded as variants. Okay. So that lines up. So I guess we're supposed to kind of know from out of band information, e.g. the protobuf, i.e. the protobuf, e.g.'s example, i.e. is like in other words, i.e. the protobuf, the proto file, I guess, the size of the thing that we're supposed to be getting. Okay. And for my, like, I guess the generic version of this does kind of make sense, but I think I'm going to start with something simpler. So I don't really want to use their thing, I don't think, because it just doesn't really match what I want. You could like adapt this thing to a fixed buffer reader, but I just, you know what, we can do it ourselves. We can do it ourselves. We can manage. We will manage. And so all we have to do is we'll say for now that we're gonna read this into like a U64 or something. So maybe we need like var int parsed varint. Maybe he'll return like consumed bytes. As well as the value. Yeah, sure. All right. So it should be simple, right? It's literally just like, is top bit 1? Keep going, right? That's it. So it's what? We start like var I equals 0, I is a u size, I plus equals 1, like a while true, I guess. I plus equals 1 probably gets deferred. And if we hit some condition, so we just like we get like const msb is equal to buff I shifted right by 7, right? And we just say if msb is equal to 0, we break. And then otherwise we just like shift the thing like val is equal to buff and 0x 7f, right? So all the bits except for the top one. T2, thanks for the raid. Thanks for the raid. For those of you coming in, we are looking at protobuf parsing because the live transit data given to me by my city is in protobuf format, and we feel like parsing it ourselves because we want, and we're trying to read the live bus data so that we can get some sort of consistency metric for if a bus is going to be here on time or not. Yeah. So that is the quick recap. I hope you guys had fun doing whatever you guys were doing. Okay. So buff and 0x7f, this needs to get like shifted to some extent. So I guess we probably want to keep track of like our shift value. And this is going to be probably Zig wants us to keep this as like a U8 for a U64 shift. Does that make sense? No. U7, U6. 2 to the 6 is what? Log. Hell, can I do like, is there fucking Python? Log 64 over log 2. Math.log 64 over math.log 2. Import math. Fuck. 6. U6. U6. So we start with 0 shift, and then we say val like or equals this thing shifted by shift. And then the shift gets incremented by 7, right? Because we're taking 7 bits at a time and slapping them on, and I think it said lowest significant first. We should least significant first. We should double check that. Yeah, least significant first. Yep. All right. So now we need like a val. And then we return the thing. So here we consume bytes is equal to I, is it? We defer increment I no matter what. So if we break out of this, I is still incremented. And I is the thing we use. So if we break out on the first run, I is 0, we come in here, we see MSB is not set, and then we break out I is 1, consume bytes is I. That seems right to me. That seems right. Seems right to me. So then we can say, down here, we'll just say switch on tag wire type, and we will say everything is not fucking supported. Ruh-roh. But we do support len. And if we are doing len, we are going to what? We're going to like read varint. Yeah. From buff. And I think we're going to do this. We're going to do var buff like this. And here we're going to say like every time we read something, we're going to like kind of change buff to like reslice itself. Right? So buff is going to kind of like indicate like where we are in the file. And then here we're going to say like, right, buff is equal to buff ret.consume bytes onwards, right? We're going to kind of do this. And then we're going to say debug print found this many bytes. That seems reasonable to me. Or like val, yeah. So this is going to be like next message is this many bytes. Won't that reslicing break the free? Yeah, it will. And you should shut the fuck up. Fine. You're right. Okay, IT. We're just gonna switch this and call it iterator. I'm joking. I appreciate the message. You are correct. All right. Fuck. 34. This needs to be flagged as a U64, I guess. He's mad because I can't and stuff with I can't and my buffer with a comp time. You know what? This guy is always fucking complaining. He's like, "Hey, you can't you can't like combine a slice in a number," and it's like, bitch. This needs to be probably like as U64, like this. Okay, next message is 13 bytes. So this almost matches what we thought. I think we thought 14 when we did it by hand, but we might also be stupid fucking idiots, right? And so I think like the test here is we should maybe if we look at this message, we are looking at this like am I supposed to foreground so I don't open it twice? If we are looking at this like feed message, and we should see that if we consume this and this, it should be done, I think, right? Because that kind of, well, let's see. We have Protoc to code this thing. So we have header, entity. We actually have a bunch of entities. So what we should see is we should see if we walk this thing, we should get the same number of entities as we get from this Protoc. And we should just be able to like fucking run that and see what happens. So we should see like one thing with tag value 1 and then a bunch of things with tag value 2. That's kind of what I expect to see here. So what we're going to do here is we're actually just going to skip the whole fucking thing. This has to be int cast probably, because I don't know if U64 auto casts to usize on x64, I'm not sure. But now we can kind of just like run this in a loop. Right, we can kind of do this. And then it should be okay? Maybe? I don't fucking know. Let's find out. Okay, so that's very promising, actually. Very, very promising. I'm seeing a lot of field equals 2s in here, and a lot of things that are like varying size of bytes. We are eventually indexing out of bounds because we finished consuming the whole thing. So we can actually do something like we can say var num items is 0. For each of these things, we say num items plus equals 1. We say if tag len is 0, break, sorry, itlen, and then down here, we do something else. We say print found this many items. Num items, boom. And he should run. He found 747 items. And I think all we have to do now is check Protoc output. Can we like grep entity open brace and then wc-l 746 plus the header is 747. So we have successfully parsed at least like the opening structure of the message, which is really good for us. That's a big win. That's kind of an indicator that this variant parsing is doing something sane in some cases. We don't really know if it's correct all the time, but it's good enough for the outside message, which is pretty fucking sick. And I think I'm gonna kind of call that like a section here. And we're gonna kind of say now that we're on 54 minutes into stream. 54 minutes into this segment of the stream, I should say. And let's try to parse feed header. I respect the check condition to break instead of using the condition on the while. Shut the fuck up. It was more that I hadn't thought of it than I thought it was better. Okay, so now what? Instead of just jumping over this thing, we want to, I guess this is a good opportunity to add test zig and commit so that we don't fucking lose it. We'll say like parse outside of GTFS feed update. Okay. Because certainly we're about to start like chopping shit up and it's going to be a problem. Okay. So I guess now what we're going to do is this else, instead of just panicking ruh-roh, is going to yeah, I don't know what I want. I think I want it to like maybe consume the rest of this section. Or we can just crash. We can just crash, but I want to at least print the wire type. Unsupported wire type D. Can I actually any? And then we can just do tag wire type like this. Oops, that's not what I wanted. That's okay. Zig run. Okay, so we got to unsupported wire type var int, which we should actually already have a parser for. Okay, and then we have ruh-roh going on. Right. So here, what am I mad about? I'm mad about this missing line. So we read 3 lengths off rip. We see field 1. Field 1 again. Then something about this doesn't feel right. Something about this doesn't feel right. But we can check. We can, I guess, check this against like the actual data if we look with our eyeballs. Field 1. Oh, no. Okay, so after the first field, we are now parsing another internal thing. So here, this is telling us that we are parsing the feed message. Then we get into the feed message, and we're immediately looking into feed header. And the feed header is seeing a string immediately. And then let's see if the string is supposed to, like, where does string come from? String is also length prefix padded. Ah, so I guess what we are seeing here is the header thing. Then this is a string of 3 bytes, which matches up with the 2.0 we saw. So this is the opening thing. Then this is the message. Okay. So initially when we were talking about getting started here, I was saying that like I'm okay with the idea of not like compiling a zig thing out of the proto message, and I'm okay with like creating our parser ourselves. So I guess this kind of indicates that like we kind of need to know which type we're working with. Right? That's like a thing that we have to do. No? So in order to like correctly handle the next thing? Well, I guess not like technically, because the raw Protoc raw decode can in fact get strings out of this. So maybe we'll just kind of like treat it like raw decode for now, and then try to like correlate with field names later. That seems reasonable to me. So in that case, there must be a way for us to identify that it is a string. So how does this know? Right, I don't understand how raw decode is identifying this thing as a string, because we only have len prefix here. Unless maybe the first byte of the string marks it somehow. Oh, I guess if the first thing after len prefix is another len prefix, maybe that tells us something. Wire type varint int i64 len s group or e group. I'm confused. I'm not gonna lie. So let's like hex dump this again. So this is first message. So this 2.0, the actual string data, comes at byte 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So this is the 2.0 here. So we have all of this stuff to get to before the 2.0. So this says message 1, length of the struct, message 1, length of the string, then this. Huh. So I don't understand how you're supposed to know which of the things it is. Right? Like, because none of, like, string bytes packed. Okay, so packed says I'm a variant. Is this the order in which I have to try to parse them? It could be that I have to try message, then try string, then try bytes, then try packed? There's no fucking way, right? Isn't there an npm package for that? I don't think you get what's happening here. We're not out here trying to read a protobuf file. We're out here trying to read a protobuf file. You know? The goal is not the goal is the friends we made along the way, not the actual end result. Okay, so where does it talk about here? Like somewhere they must talk about how I'm supposed to determine if it's a string or not. Blah blah blah. More ender types. Like I don't really care about that. I'm kind of more interested in the. Here we go. So a record for the field B is length prefix, then you have the string testing, and so the result is this shit. In Protoscope, this is written as blah 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 blah. Okay, sure, don't really care. Sub messages also use the len type. Okay, yep. Now, how does it know? Do they tell us how we can tell the difference? Sub messages also use the len wire type. Here's a blah blah blah. The last 3 bytes in this are exactly the same ones as in our very first example. The bytes are preceded by a len typed array and a len typed tag and a length of 3. Exactly the way strings are encoded. Exactly the same. Okay, so like that's what I'm like fucking freaking out about. It's like if it's exactly the same as a string, how the fuck are you supposed to know? How am I supposed to know? I guess we could look at the code in Protoc, but that feels like a little bit like cheating. Packed repeated fields. Field order. Do not assume. Okay, I don't really care about this. Okay. Maybe they'll talk about it here. A length is stored as a length, then one of the listed data types. Yeah, I'm pretty lost on how the fuck I'm supposed to know which is which. Guys, we're gonna ask the dumbest guy on the internet. In a protobuf, how am I supposed to know if len prefix typed messages are messages, strings, byte arrays, etc.? Okay, no, shut the fuck up. Shut the fuck up. Don't tell me to check the fucking field type. I understand that, like, fuck you. Field type is straight. Okay. Dynamic. If you're dealing with a dynamic, okay. Fuck you. Fuck you. What about if I don't have the proto definition? This guy's so okay. So yeah, okay. He's basically saying what I was saying. You just fucking guess. You just fucking guess. ChatGPT is such a yapper. Yeah, he is a real yapper. So we could look at like maybe like Protoc source code and try to figure out what happens when they type raw decode. I assume that they have some heuristics that they're using, we just copy, or we could just actually like we could just know the correct answer. But I'm a little curious still, so let's just fucking take a little peek skis. Give him a sec. He's got to think. He's a thinking boy, and it's gonna make his brain strong. This is so stupid. So there's like decode raw is like somewhere. Command line interface, decode raw. That's not what I want. Where is the like decode, if name equals decode raw, where do they like, where do they parse this thing? If value empty and name decode raw does not take a parameter. So here they're like, if I see decode raw, dude, what a parser. Oh, my fucking brain. Okay, so Jesus Christ. Bruh. Okay. So here they say I'm in this section here is where we handle the decode raw argument. We are in, I guess, mode decode. And if value is empty, what a weird way to parse this. Okay, so we're looking for somewhere where they use mode decode, I guess. Define empty. That's pretty funny. I like it. I like it. Okay. I like the idea too that their function is called encode or decode. Like those are the same fucking things. That's kind of funny. I just want to know, like, figure out where they're like. Do they have like a fucking decode raw decode.c like? Oh, if we are in mode encode or decode. If mode, else we print the thing, else we parse partial from 0 copy in it, input is binary. This is too much work. This is too much work. I just wanted to find their heuristics. Because this unique pointer message. Okay, yeah, this is going through all sorts of crap. I don't want to figure it out. We'll do it ourselves. Yeah, just fuck it. Fuck it. All right. So I guess we have to use some sort of heuristics. So we're gonna do something like, if we see len, we have to like guess if string, if message or string. So I guess we can maybe try to like parse this. I can't believe you almost said fuck you to Jiminy. That's wild. I mean, I feel like he needs to know that he did bad, you know? So maybe we want to put all of this stuff in like parse proto message, right? And this way we can kind of slice the thing, and if this fails, then we continue and try to parse it as a string. That feels reasonable to me. So we'll take some sort of like input buffer. And I don't really know what we return here, but it really feels like we're going to do this. Like everything that we're doing right now feels like it just goes in here. And then the only thing we have to do here is recursive call. Gross. I guess we don't want to recurse here. But we do have like some sort of like stack of messages that we're parsing, right? Like if we have message and message and message and message, we do kind of want to call this 4 times, I guess. And I guess the recursive call isn't that bad because like we are only going to recurse as many times as there are nested messages, which shouldn't happen that much. So I guess it's fine. I try to avoid recursion generally because I don't like the idea of stack overflows. But here I guess I'm okay with it. So surely this thing can fail. And I guess we'll just say like parse proto message iterator. And then here we'll say that the iterator is updated after this to be the var. What's the return of this like read variant? Val. Yeah, so we'll try to parse this thing and then we just immediately fucking send it onwards. And then try again. So this all goes in a loop. That makes sense. And if this fails, then we try parsing to the string. So maybe we like log the we hold the error just in case, and we then try to parse it as a string. Okay. So this is gonna be like, I guess kind of for both of these, we kind of want to like go up until the length, right? We kind of want to do this. And then, I don't know, this returns back the string, I guess. And he can fail, certainly. And parse proto string. This actually does jack shit. This just return buff, actually, because we've already kind of parsed up the length of the string. So I guess we want to do like stood. Like, is there like a UTF-8 validator in our standard? Fuck, alt tab's broken because of the fucking K widget we're doing earlier. God damn it. Zig stood lib. Is there like a UTF-8 validator in here? It seems like the type of thing that they might have, but maybe not. Stood Unicode. Sure. And it looks like there's like a decoder in here, and we can like, whoa, okay, let's not get ahead of ourselves. Like U21 return, that's not what I want. I just want to know, like, are we fucking sane? UTF-8 validate slice. This is what we want. This is what we want. Alt tab broken, so I'll just click this fucking Firefox icon like 40 times and realize I'm not trying to go to Firefox. I'm trying to go to my fucking terminal. So if stood Unicode is validate UTF-8 slice, whatever the fuck this is called, it0ret.val. Maybe we're gonna say like that the const inner is it0 ret.val, and maybe even here we'll just immediately fucking then send it as like I do this here. Then here we say inner. Boom, 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 boom. Then I guess we just like stood debug print got string s, and then what are our other options? Bytes or packed? Fuck packed, I guess. So I guess we'll just assume that it's bytes otherwise. Else got bytes like this. And then I guess we just don't fucking log an error here ever. Okay. I guess this now goes, this looks more like an if else. This kind of looks like this. Then we say if else, discard our fucking error, and then we do this stuff. There we go. That's looking good, baby. DuckDuckGo has a bang for Zig. That will save me time, actually. That's pretty fucking sick. And then here, if we get a message, we just say parse proto message message. Yeah. Okay. Now, I guess if we're printing shit, it probably makes sense for us to keep like an indent level. Probably, right? Like, so that we can kind of like visually track this stuff. So maybe we'll call this like indent print. And we'll take in like a comp time format. And then we'll take in like an indent like this. Then we will fucking take in some args and any type. And we'll call debug print with the format and stuff. You know, we'll do like format args. But then before we do this, we don't want to quote format. We just want to pass it along. But before we do this, we're going to be like nothing, please. But we're going to for 0 to indent, fucking slap some T's in there. This, boom. Which means now all of these to debug prints gets replaced with like indent print with the indent level. Indent print with the indent level. Indent print with the indent level. And another one. And I finally got the right thing in my repeat buffer, so we can just slap some fucking dots in there. And maybe this does something. I don't know. Don't ask me. We're not out here knowing if our code works. We're just fucking sending it and seeing what happens. So here we rut road before any indents, which is surprising. I expected here for us to see something interesting. Oh, I guess we didn't actually ever call our function. That's a really important part of this. We actually have to do this. If you want to run the code you wrote, you have to call it, and that's important. And then also when we recurse here, we have to increase the init level. And this seems fucking stupid. We don't want to do it again. We would just want to kind of like do nothing here, I guess. That makes way more sense. He's bitchin', whining. Invalid format string D for type struct U64. Because args here, we nested the args again like fucking idiots. Let's just go like this. There we go. This looks promising. So here I don't see anything where it says the string here. Next message is 3 bytes. Are we not supposed to... Oh, this fails. And he panics because we just fucking... so we need to do some bounds checking here. Which is totally fucking reasonable. So this is at 79. So here we can say if ret.val is greater than it_len, return error invalid len. Here we go. So that got string 2.0 is looking pretty fucking tasty. He's forgot to new line at the end though. Looking pretty tasty. Okay, so now we have this, got a message, got the string. Here, I guess we almost want to like buffer our prints for if we fail, which is kind of interesting. Or we just don't do this. Let's take a look at that. Or like this. Is that reasonable? I don't know. Yeah, I guess we kind of want to... Maybe at the end, if we get through everything correctly, we print this stuff at the bottom. Kind of do like this or something. But then this kind of like is in the wrong spot. I don't know, man. I guess we leave it for now. I'm not really too worried about it. If we have a little bit of extra printing, it doesn't really matter. It's fine. We are now at a unsupported wire type var int. So this is within the header. We are reading the second field and it's a var int. So that is in the feed header. We are trying to read this field, which is a var int. So this thing should be 0 or 1 is what we should end up seeing here. So we can just start supporting var ints here. So this is just like read var int of it. This will return us some value. We say it is either this, you know, we just keep going. And we print the ret. So this is just got int with a new line. And we say, here it is, baby. He's mad because D is not fair here because we need the val. We need to print the value, not the fucking struct. Okay, so now we got int 0 and then got int 1720409 4397. This looks kind of sketchy, so it'd be nice to kind of compare this with the Proto C output. Proto C. 1249828. Interesting. So we do, the big number is totally fair, but we're getting like different big number, which is kind of interesting. 2.0, 172, 4093, 24093, 24094. Why? That's very odd. Actually, like, very strange. It's like, how is it this close? And is that 397 in there anywhere? I guess if we're constructing the thing wrong, but like not that wrong, then that could be a problem. Could be a problem. Yeah, so maybe we try to figure out which bytes are associated with this. Bit shifting not perfect. Yeah, it does kind of feel like that could be it. We could maybe look at this. Okay. So let's do, what are our two values? We have them both here. So we have this thing, right? And this thing. Okay. So can we like print like a Boolean, how do you call this? Like bit binary representation of both of these and see if they like kind of line up in any way, shape, or form. Just like this. There we go. And fuck. This, like, what are we looking at here? It's literally the same number except for the last bit. Right? No. 1 1 0 0 1 1 0 1 1 0 0 0 0 1 1 1 0 0 1 0. Okay, so here's where it starts going wrong. And is this 7 bits or something? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Kind of arbitrary, kind of where it's starting to fuck up. Did you remove the leading ones from those bytes? Did I? I thought I did. Like, by the leading ones, you mean like the most significant bit? I mean, here I'm doing like a 0x7f ampersand with the value. And ORing that into the value shifted. Right? So I don't really see how that should be a problem. It might be interesting to compare this to... It's interesting that it's like the right number of bits. Right? Like these guys are both... Like the MSB parsing must be right. And it's also interesting that like 0, 1, 2, 3, 4, 5, 6... Or 1, 2, 3, 4, 5, 6, 7... 1, 2, 3, 4, 5, 6, 7. Oh! Okay, so the first 3 chunks of 7 are all fine. And it's the 4th chunk of 7. One, two, three. Yeah, it's like the 4th and 5th one are wrong for some reason. For some fucking reason. So this is in feed header. We have, this is uint 64 is what this is supposed to be. So there's nothing crazy with like signed integer bullshit going on. Shouldn't be. I'm actually quite confused. Unless Xerx7f is wrong somehow. But I don't see why. I can't imagine that that's not right. And what are we seeing any like interesting, so I can't remember. Fuck. Python 3. Can we look at this from, was it 21 onwards? So is there anything interesting here? Like, so let's also confirm that this from 0 to 21 is equal to this from 0 to 21. We did it with a hand, but that is the same. So it's very interesting that is 21 onwards. 21 onwards and like totally, like what feels to be like totally unrelated. Very odd. So how many bits is this? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits. So this is two more things parsed. It's very strange, very strange. It's weird to me that the first ones work okay. Can we like GDB? Yeah, I guess we just want to pop up on the debugger, huh? And that's going to be here. Little endian means the problems with the first and second byte we're parsing, right? Because Python prints in big endian. Oh, maybe. Yeah, that's a good point. Which is even more confusing, to be honest. Because we are... That's even weirder. But yeah, I think you're right. What the fuck? Okay, Zig build exe test Zig. GDB test Zig. Break here. Run. No. Really? Oh, because I tried to test Zig, not test. File test. There we go. Break here. Run. Step. Okay, I don't know what I'm trying to understand here, but you know, let's just kind of take a little peek see. So can we like print the whole buffer, dereference it, and look at the next 7 bytes? So the first byte in here is totally 0, which kind of means that this varant is going to be like totally fucked. Right? Because this has MSB of 0. So we break. Where is this happening? So the value returned was 0. Oh, oops, it's the second variant. That's why. That's why. Okay, step. Let's print the p buff len 5. So let's read this thing now. Okay. Fuck these numbers. Can we print them as like a unsigned car star like this? Really? How do I get them printed as like hex? Print hex GDB px. Yeah, that sounds right. There we go. And then so we have BD. Can we like print as Boolean? Can we, or binary, I mean? Can we do GDB print binary? Oh, he said it right there. It's p/t. I wonder what the /t is for. Okay, so all of these do have leading ones. And we have 0, 1, 1. We have 0, 1, 1, 1, 1, 0, 1. And does that match up with anything we see here? 0, 1, 1, 1, 1, 0, 1. So this isn't the number we're seeing. I would be willing to bet that there's something I think we saw in the encoding thing when we were looking at this. Use the same coding for unsigned integers, but encode signed integers by prepending the sign as the least significant bit of the first byte. So I wonder, like here we are saying least significant bit is set, which might change something. So we're seeing the bottom bits we think should be 1, 0, 4 ones and a 0 maybe. Which doesn't match this at all. Very confusing. Maybe we should read the protobuf variant encoding again, because it's like pretty fucking clear to me that like we're fucking getting these numbers, and like hex dumping this thing. We're looking for BDAF8E. BDAF8E, right? So this like, unless this 1/8 supposed to be part of it, right? So this is the 0. Then the 1/8 is the tag. Yeah, that 1/8. This 1/8 here is saying that we are a var int for field number 3, right? If we take 0x18 shifted left by 3, that's field type 3. One of these is like, I can't remember. Hold on. Also, 31 isn't possible here. Right? Am I stupid? This should be 8. I don't know what the fuck is going on here. But we saw that this is supposed to be the field number 3 wire type. So field number 3 wire type 8. No, 0. 0. Which is a variant. Right, so that's what the 0x18 is. Should be and. Oh yeah, that would do it, huh? Thank you. There we go. Wire type 0, field 3. So that's what the 1/8 is in there. And so here, like BDAF8E, this or all of this, these 5 things have to be the variant, right? Like this just has to be. It would be kind of interesting also to try running the LEB 128 thing from Zig standard library to see if it agrees or disagrees with protobuf's implementation. I mean, it must. Protobuf's implementation has to be right, but I just don't really understand why yet. So let's just, break down the problem. We have to break it down just to make sure. If Zig standard library agrees with us, or agrees with protobuf, it means that we can be sure that we're at least looking at the right data, right? So we can say go into this thing and read these. So 0x, 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 0x. We kind of slap some array shit in here in front of here. We put these like this, like this, like this. And then we can say const buff is equal to this. And then we do std io fixed buffer stream around our buffer. And then we get s.reader like this. And we say val is this. And then we std debug print our value. All right. Zig run test2 dot zig. He's mad because probably this needs to be var. Nope, this has to be var. He's mad because Well, I actually don't know what he's mad about. Cannot format error. Oh, this is me tried, I guess. 4-3. This is agreeing with us, I think. We're seeing 397. This printed 397. Is this field signed or unsigned? It said unsigned. But it just means that we definitely, so the fact that Zig's implementation agrees with us, it really indicates that we're not doing anything crazy. I guess also when we call decode raw, it can't know if this is signed or unsigned. It doesn't know. It's just making a guess. So can we decode without raw? Fuck my... Oh, okay. Okay, so it's because when Protoc decode raw is just like guessing shit wrong. That's so fucked. Okay. Okay, so that's actually a really good piece of information for us that the approach of doing a raw decode is inherently flawed. And we shouldn't even be going down that road. Which means that we almost want to like immediately jump into defining an interface to parse this header like from like immediately. I think that makes sense. So let's define, I guess, a type feed header. Okay. That has these things in it, right? And this is a string. This is a we'll call it a U8, I guess. And a timestamp is a U in U64. And we will just make a fucking function on this that takes in a buffer and returns a feed header. And he is now going to like parse this and just expect that it's right. Dang, that took a minute. And if you didn't want to raw dog your parser, you would never have known. Learn something new every day. This is what I'm talking about. Yeah, let's go. You have shoehorned in a lesson learned that justifies our bullshit behavior. So thank you. And yeah, there's something nice about that. This is why we do it. Is because that actually is like valuable knowledge for if we're ever working with protobufs in the future, right? Because like I would have definitely just trusted decode raw forever until it bit me in the ass, and it bites you in the ass so much faster when you do stupid shit. All right, okay, so here we're gonna instead of doing this like while loop, I guess we kind of can just expect a certain format here, right? We expect that we're gonna have a string, and then we expect that we're gonna have shut up, I can't remember. Incrementality. So this, I actually don't know what we expect here. I guess kind of like U8 is fine. Because here he's like enum, and then we expect unit 64. And yeah, we just kind of expect these things to be encoded in a very specific way. So maybe we have like protobuf parser. He kind of holds his like buffer. And maybe on here we have methods to kind of like extract different things. There's a binary message format I think called code generator request. I forget how you can get Protoc to parse a proto file and spit out one of those. Ah, interesting. Yeah, I think I saw that in like the protobuf, like the protobuf plugin documentation stuff. I think I saw something around there, but I didn't really read it too carefully. And I think I'm gonna do it by hand because I think that's kind of like more fun for me. Okay, so maybe we'll have like a pub function that's like read tag. And this is going to return a tag. And this is just kind of be this. I guess I'm not going to delete the other stuff yet, so I'll just forward this on. So this will be called read tag with self IT0, I guess. And this is going to take in self as a protobuf parser. And we're going to return this. But before we do this, we're going to say, oh, fuck, ambiguous reference. Fine. Read tag, ugh. How do we disambiguate? Fine, I guess we'll just take everywhere that calls read tag right now and replace this read tag impl. There we go. Just for now. And then I guess this is going to automatically consume the iterator. So we're going to actually have like const ret is equal to this. And I guess this is actually just going to return the tag like wire type directly, because like externally we don't really care about the rest of the stuff, right? Like we kind of just like we kind of want like the protobuf parser to be in control of maneuvering the iterator, and we just want like the data itself out, right? So maybe we'll actually call this like read wire type. Then we will return parsed. This probably has to be tried. We'll return the wire type, but before that, our self IT is going to equal self IT from parsed consume bytes onwards. Yeah. Okay. Then we can kind of move on, and we can add something like function read var int, or we could even kind of like slap this all together into like one function that's like read next, right? You could even do something that's like next. Oh, I kind of like that. I kind of like the way that's looking in my head. So first of all, this can't be const. That's fucking stupid. I'm gonna get rid of this, and this is gonna return like an output. And this output is going to be a union kind of like flagged by the wire type, I think is how this works. I don't fucking know. Okay, don't fucking ask me. Right, and I assume that here I have to like set all of these things in here. Right, so here this is going to be like a U64. This is going to be like an I64. This is going to be a U64. S group and E group are going to be, I guess, unimplemented. And this is going to be another 2. Then here we're going to like read the, then we're just going to do like one chunk of work, which is very similar to like whatever is going on in here. Right, but he's not going to do this while loop. He's just going to do one fucking iteration of it. Yeah. So he's going to read the tag from self IT0. Self IT is equal to self IT onwards. We're not going to print shit, right? We're going to look at the wire type and fuck this counting of num items. If it's a length, we're going to read the fucking var int. Is this the idea to replace Google Maps as a commercial product or a project for fun? Always just for fun around here. We hate doing something that's actually usable, right? Because it makes it not fun, right? We're here to code for fun. The product is the stream, which is kind of funny. It creates all sorts of fun, perverse incentives. Like instead of using a protobuf parser, we write one our own because it's like this is a better stream and more fun for me. But it's an overall worse thing to be doing, which is kind of fun. Okay, so this thing returns a parsed variant. So this is going to be like, I guess it's fine to call it ret. We iterate our consume bytes. And I guess we just want to return here. Here we almost want to return like the sub thing. We almost want to return like a new protobuf parser, which is kind of funny. Right? Like we get back, we say like we got this thing, and like you have to decide what you want to extract from it. I think that makes sense. So here we're gonna say like our new parser is a protobuf parser with IT is the existing IT from 0 to ret not consume bytes. It's from, I guess it's here. It's self.it from 0 to it.len. But we have to only do this in this case where we are allowed to do that. That makes sense. And then here, this is our inner thing. Oops. Which I guess we just continue on moving this shit around. So this comes from inner, like this. So this can actually just like self dot. This goes here. This goes here. Then we, expand ourselves onwards. And then we don't do this like recursive parse. So here we just return len. It's like, what is it? Like dot len is equal to new parser, I think is how you do this. Yeah. Okay, so on varint, we have self.t. Fuck this indent print. We increment our iterator. All of this feels good. And then here we return varint is equal to ret.val. Otherwise, we panic. And we say, or maybe we just do like a stdio print here again. Oh yeah. This is feeling pretty good. Pretty good. Okay. So then when we parse our thing, maybe this doesn't return a protobuf parser, because we don't know if this is going to be another message or if it's going to be a string. So I'm going to turn this back into a const u8, and we can choose to make this thing a protobuf parser if we want to. But instead, we are just going to return like this and then defer this. There we go. It's fun watching the code go from like a massive fucking blob of shit into something that's like kind of, acceptable. Like this on its own is like almost something that I would allow myself to push for review. I mean, other than this, but like, like the part that's implemented doesn't feel that bad. Okay, so now we want to do like a protobuf parser of the buff, right? I guess we want to like init this thing, and instead of init this thing, we can just do like, we can do a little bit of understanding his internals. We're okay with that. And so we want to say that like parser next should give us, this should give us the GTFS real-time version, right? But this is kind of like union, right? This is like, it might not be that thing. So then we have to say like, if GTFS real-time union is not equal to len, we're like, the fuck, bro, right? Like return error invalid GTFS real-time version type, right? Something like this. Like, ew. Big, weird name. Gross, man. Okay? But, otherwise, we can say that the GTFS real-time version is equal to this len. Easy, right? Simple. Yeah. Okay, let's just start here. Let's just start here and see if this like kind of makes sense. So maybe even before this, we have kind of like the feed. What was like the top level message? It was like a feed entity, I think is what it was. No, it was a feed message. Feed message. And right, like he's gonna have like a header. and other stuff. But for now, we'll just kind of leave the header as the only thing, and we're gonna have like another function for him. Fucking parse me, please, and he's gonna return a feed message. Why are these things? Why did I use two indent there? Two space indents. That's kind of weird. For now, we are just going to return this thing as GTFS time version is equal to GTFS real time version. We're going to return incrementality is equal to 0 and timestamp is equal to 0. We'll fucking get there, but for now, we want to get something. Here we are going to construct a parser, right? We have a parser, and at the top level, we expect to get the header, right? This is what we expect to get. I think this is gonna fail, so we should actually hit try here as well. And then here we say if header union is not equal to len, then we have a problem. Now there's something missing here, where we're kind of missing like validation of which field we are. Right? There's something kind of odd here. I don't remember where that came from. It was that we read a var int. Read var int. Next message is 8 bytes. Where do we get the field number from? Oh, that was from read tag. So our output thing here, this should return the tag. We lost the tag field, but I'm not going to deal with that right now. Because we need to see some incremental progress, or our stupid little monkey brains are going to like explode. So here we're just going to say our header is equal to a feed header. No, this is a fail. This is an error. Return error invalid header. And then here we say header union len. And we say const header is equal to feed header parse this thing. Oh, it's all coming together like really well, actually. This actually feels like a really reasonable interface to me. All right, so here we can like fuck this shit, and we say feed message parse our buffer. And I think if we've done everything right, we should see a message get printed here. Any. That is what I think we should see. We want to run test.zig, not test. Fuck this test2.zig. Who cares about test2? He's mad because at 133, we need to write that this is a variable parser. He's mad because 133, he needs to write. Oh, does this not? This surely can fail, right? Yeah, there's tries in there. We just didn't write them down. We're missing 142. This needs to be tried. Lots of tries. Parser next at 112 is mad about this thing not being a variable. Oh, baby. Come on, that's awesome. Okay, so that's working. All of this is right. Nothing's fucking crashing. He's giving me this 2.0. He's just not printing him as a string, but that's pretty fucking sick. And so now all I have to do for this parser is just like kind of just keep going on this like parser.next, right? So here we're gonna get like the incrementality union, and then we're gonna get the timestamp union. Right, and here we're expecting, I don't know if we can expect that this thing has to be a varant. Like the protobuf compiler might choose to make it like not variable, but for now we will assume, we'll say like maybe could be any int type, right? In which case maybe we actually fix this now. We can maybe say this, no, I'll fix it later, right? You could make a function that's like get u64 that does like any casting that you have to do, but for now we're just gonna say assume. If this is not equal to a varant, then we have a problem. unexpected incrementality or something. I don't give a shit. And if timestamp union is not equal to this, we'll do the same thing. Unexpected timestamp. And then here we just say like incrementality union far in for both of these. Fuck. Expected U8, so this is incast. Oh, that's so fucking sick, guys. That's actually like it's so sick that I didn't plan this at all. Right? Like we kind of just started poking and prodding, and we ended up at what I think is like a totally fucking reasonable interface. This is so cool. Like we have this like kind of like generic protobuf concept now, and we can kind of just be like next, give me the next field, and we should be able to like we now should be able to extend this to entities, right? Entity, and this we know has like many of them, right? This is kind of what we saw there, and so we can say like const feed entity, and we can just fucking implement this like right now, right? So we have like feed entity. We have like for now actually, let's not I don't really want to write the parsing for this because it's like kind of like a lot of stuff, but we can maybe just at the very least skip. We can maybe get their entity ID, right? Let's just parse all of their IDs, right? So we'll do like this, and we will do this, right? Essentially this same thing, except the GTFS thing gets replaced with real-time version gets replaced with ID, and then we return ID is like ID. Invalid ID, right? And then here we say, I guess this next needs to kind of bail out in some way, right? So we can say like if self.it_len is equal to 0, return null. And then here we will, everywhere we call next, we'll kind of just, I don't really know how to like, I think it's like this, maybe. Put like some braces and auto open the optional. We'll kind of just assume that everywhere we use it right now is like right. And then here, this is the same. So here's the same. But then here, now we can say while try parser next, we get some val. We expect that these vals are going to be len. So here we'll say return error invalid entity. And then we will say feed entity dot parse this val len, and then we will append these to our entity list. So here we'll say like var entities is a std array list initialized of feed entities initialized with our allocator. Defer entities.dinit. Here we have entities is equal to entities.toOwnSlice. Bing, bang, boom. Allocator gets pushed into our parse function here. And we don't have the allocator thing type def, so allocator is equal to mem allocator. Oh, guys, it feels so good. It's just like all this is just, it's just coming together so well. And so now all we have to do here is just on each one of these, we say like entities.append, try this parse thing, and then we should be fucking good to go. Fuck. It's never right. It's not right. 156. It's because here we forgot to change this to feed entity. Oh, it's so like, look, we got like an ID for each entity. It's so sick. It's so easy to stitch these together now. And if we look at entities.len now, it should be like whatever the right answer was, like 167 or something, 166. I can't remember. So we can look at message entities len. Fuck. feed message does not support error union. What the fuck is it complaining about? We probably have to try this. Yeah, 746. I think that's what we saw when we did our like wc-l command. 746. It's so sick. It stitches together so fucking well now. Yeah, it's pretty cool. And so now all that's left is for us to kind of tack on the remaining like components of this feed message. So it's kind of just going to go through like GTFS real time. So probably the rest of this is going to be like, we have some more types to define and parse here, right? All of this stuff. But we can kind of get a little like tricky here, and there's a bunch of things in here that we probably don't care about, right? So we can probably like ignore most of this. We can probably the only one that we think we should care about is vehicle position, right? So like we can look through these things. We can say like we'll figure out how to like unparse, like get rid of the optionals. We'll see if we see a vehicle position, then we'll define a thing for that. And in here, we probably only care about like trip descriptor and position, right? So we can kind of like avoid things that don't matter, and kind of like lazily parse only the things that we want. And yeah, I think that our like the beginnings of our parse interface really seem like they're going to support that well. So I think I'm going to call it there for today because it's a 4 o'clock, which is usually when we try to end it. I appreciate those of you who have came in from raids today. I hope you enjoyed what you saw. If you like what you saw, we stream most days at around 12:30 Pacific time to around 4 o'clock Pacific time. There's a YouTube link in the Twitch description. It's a little picture, not like a URL, which people get confused by a little bit. But if you go there, you will see, well, you know, all of our previous work organized in the playlist. So if you want to check out, like the map edit is what we're working on right now, which is pretty fun. But there's also like, there's an operating system in here. There's a video editor, there's a QR code decoder, there's a ZLib implementation. So if you want to check any of that stuff out, it's there. The code for this will eventually end up on GitHub. I don't know where it's going to live. It might live in a new repo, not really sure yet. But if you want to check out the map stuff, that's in here for sure. There's a Discord link in the description if you want to get updates about when like VODs go live, when I'm going to stream. If you want to just like chat about shit offline, that's all there. If you're watching on YouTube, there's a Twitch link in the YouTube description if you want to swing by and say hi. YouTube guys, you're seeing the 2 to 4 segment. There's a 12:30 to 2 segment, which is kind of more vibey. We're kind of like more working on not really like new feature development, but like cleanup, chatting, talking with chat, listening to music. So if you guys want to check that out, that's there. And they're archived on Patreon with no music. Links everywhere. Okay, I think that is all we have to plug. So YouTube, goodbye, and Twitch, let's find someone to raid.